And you know, this is a quite obvious consequence of the population increase. Population increase, which is very relevant, as you see, of course, is giving an increase of population which is higher than average in the lands that were not so populated in the past. Because of course, if you have a restricted population, you occupy the zones where you have plenty of water first. But with the increase of population, you are forced to occupy also the lands where you don't have plenty of water, that were not considered before. And therefore, it's quite obvious that in water scarce area, you have an increase of population. But this means that you get an increase of the population that is exposed to droughts. And here, what can you see? You can see here an example from US again, which gives the decrease in groundwater level after the increase in population. Because of course, if you overexploit water resources, what you usually do is to take water from groundwater, because of course, in water scarce areas, the prevailing water source is groundwater, because usually in rivers you don't have a lot of water available. And therefore, with the increase in population, you may have an overexploitation of groundwater, which means a decrease in water level. Not necessarily. You may have a decrease in water level even if you don't have overexploitation. But of course, a decrease in groundwater level is an indication that something is happening and needs to be considered. Let me give you now a brief description of recent droughts worldwide, so you get a perception of the problem. Sorry. Here you have a brief history of drought in Europe, and the history goes back just 40 years. We had droughts in 1973 in Central Europe, and the impact was a very dry winter, spring resulting in low snow melt, and subsequent water shortage. So it was a drought originated by a dry winter. 1976, Northern Europe, Scandinavia to France, unprecedented 16 months duration in UK, drought duration, led to massive subsidies, claims as building foundation failed. Subsidies claims, sorry for my pronunciation, means that people asked to be refunded from damage that derived from subsidence, lowering of the topographical surface. French milk yields were reduced by 25%, milk production, and and there were other problems with agriculture. 1984, North and West UK, very dry spring and summer led to the imposition of hosepipe bans. I don't know the meaning of hosepipe. Pipe is 2 balls. I don't know. I will give you this information tomorrow. 88-92, most of Europe. Anomalous circulation pattern caused rainfall deficits over a large area, interspersed with short wet periods. Insured losses due to subsidence estimated at £600 million for UK alone. So again, subsidence. Then, 1992, Germany, Hungary, Bulgaria, and much of Western Russia. German crop production reduced by 22%, irrigation suspended in Bulgaria, worst Russian drought in 10 years. And then from 90 to 95, look at the duration, 5 years. Spain, Portugal, prolonged drought across the entire Iberian Peninsula. Water supplies in Seville were cut for up to 12 hours per day during 92-93, 2 years. hydroelectric power suspended in 94-95. 1995 in Ireland, UK, Norway and Sweden, agricultural losses in the UK were valued at about £200 million. Reduction in Norwegian hydropower capacity led to 600% increase in mean weekly prices. Increased 600% increase. 1999 Finland, hot dry summer resulted in a very low water levels in rivers and groundwater. 2003, you may remember this one, much of continental Europe, many deaths from unusually prolonged high temperatures, forest fires, subsidence, power cuts and agricultural losses. And you may remember this drought. It was given by about a 3-month period in which no rain occurred over practically all Europe. It was a wonderful summer, if you remember, but from the point of view of water resources was really tremendous. This is a map. It's not very clear here, but it's a map that is showing the geographical region interested by the droughts that I mentioned before. I told you that this history of events goes back to 1973, and there is a reason for not going back farther. And the reason is that before 1970, water resources were not a matter of concern. The effect of droughts was less severe than now because of lower population, of lower exploitation of water resources, etc. Now we have to look at the future, of course. And here we call into play the predictions. Predictions by climate models, which are affected by a relevant uncertainty, which is usually not conveyed. But let's look at this map. In blue, you see countries with little or no predicted water scarcity. In red, countries with physical water scarcity, meaning that indeed water is lacking, will be lacking. And in yellow, economic water scarcity, meaning that water scarcity will be resolved at the expense of economic efforts. And we see a picture that gives us a quite obvious idea of the situation. But we can see from here that about half of the world is affected by water resources, heavy water resources management problems. I say heavy because we have water resources management problem even in Italy, even if you see that Italy is a blue country, although there is a light blue, which means that it's more vulnerable than the deep blue countries. This is a quantification. Water scarcity index is a way to quantify water scarcity. And the water scarcity index is given by the total water withdrawal minus desalinated water. So desalinated water is not taken into account in the total water withdrawal for a country, total water withdrawal for a country, divided by the renewable freshwater resources for that country. What does it mean renewable? Means water resources that are whose cycle of renewable, the time that is taken to renew the water resources is less than 1 year. Which means that in 1 year time, in a season, let's say, the water resources are renewed. If you are using water resources that are renewable, you are quite relaxed because you are using something that every year is replaced. But if you are using water resources that take more than 1 year to be replaced, of course you get a bit more concerned because, of course, if you continue using these water resources over the years, and they take a long time to be replaced, you end up finishing them. And this water scarcity index, it is depicted here, and it's a current situation, which was quantified in 2006. There is the reference up there. And you see the indication here that the water scarcity index is higher than 0.4. You get into a water stress. And here you have a picture of the overall situation. 0.4 is in the middle of the red color. And you see that there are a lot of countries that are experiencing water scarcity, including Italy. Accordingly to this definition, which means that, you know, it's a quite safe definition, because it means that these countries are using more than 40% of their renewable resources. Let's now have a look at the domestic needs. These are order of magnitude which are important, and in particular this indication here, which you already know, because I think you studied in some of your previous courses what is the per capita use of water. And this indication says that in high-income countries like Italy, people use typically the dotation of water, the supply of water to any person should be calibrated accordingly to the range 100–600 liters per person per day. And the reason of the variability is mainly the size of the town, city that is served. If you have a small town to serve, you can use less water than in big cities. The reason is that in big cities you have additional water consumption due to washing the streets, industries, because this is an equivalent dotation, which includes also industrial use. Doesn't include irrigation, because this is an indication that is given for designing civil water supply systems, which usually also serve industries but don't serve irrigation. So this indication includes, again, water consumption by industries but not irrigation. And again, the reason for the variability is the size of the water supply system. If you now look at low-income countries, the dotation is about 50–100 liters per day. And if you go to water-scarce area, the dotation is 10–40 liters per day. I can tell you that if you make a practical experiment, to use for yourself less than 20 liters of water per day is really challenging. If you try to make I usually do this experiment not because of curiosity, but because I travel with my family with a camping car, and I have a clear idea of what are water consumption uses for civil use, even if you try to really minimize, because you know sometimes you have really to save water because you don't find any water for the camping car for some days, and to use less than 20 liters per person per day is really very difficult. Okay. You can do it, of course, but I would say that the minimum is about from 10 to 20. And of course, an important issue also in determining these numbers is water leakage from the water supply systems. So the losses of water, water losses. And this is an important issue, which is very relevant because you must take into account that even a very efficient water supply system loses about 20% of water in delivering for leakages. And this gives the reason for the extreme importance that reducing water losses is playing now. Also, from a research point of view, a lot of effort are being spent for reducing water losses. This is indeed something that has to gain a high priority for the future. Reducing water losses, and irrigation is even worse. Irrigation networks lose about 50% of water when they are very efficient. It's very difficult to reduce below 50% water losses in irrigation network. Here there is some indication about, you see, what are water needs for humans. A gallon, if I'm not wrong, is about 5 liters, I would say. I would say 5 liters, yes. And so you see that in the minimum for the is consistent with what I just told you. It's about 15 liters per day. And then there is the urban use. You see that if you multiply times 5, you get again the indication that I gave you before. And also here there are some indication of gallons of water needed for making assigned quantities of agricultural productions, kilowatt of electricity, etc. And keep in mind this indication here of the amount of water that is needed for producing cotton, which means that cotton is very water expensive. This is important to remember. And here there are some other indication. You see 1 10-minute shower, 25-50. Okay. Just to understand a little bit better what are the involved needs. Okay, here there are some other indications. We already saw this indication here. And you see that if you assume that a person uses 100 liters of water per day, you get a total quantity over 1 year of 40 cubic meters per second. And if you shift to 600 liters per day, you shift, of course, to 240. But if you look at the agricultural needs, you see that the need is much and much greater, about 1 order of magnitude. So if you look at the total amount is about 1,000 cubic meters per person per year, but 80% of this total amount is given by water for food. This is important. I already mentioned to you that the higher water consumption is related to irrigation, agriculture, which means water for food. And here you see a map of the water stress, and you see 1,000 is the quantity that I mentioned to you before, is in between yellow and light orange. And you get a picture here. And while there are countries in which you have a much higher water consumption. Let me check. Okay, this is not important. Now, I close this lecture by talking to you about the Lake Aral disaster, which is another example. An example of an incorrect water resources management. Remember that we are talking now about problems, So I started with floods and drought, and while talking about drought, I talked also about water needs. Now let me go back to problems. And this is an example of bad water resources management. And beside this picture, I want to show you, this is a picture of Lake Aral in 1989 and 2003. 89, 14 years passed from the first shot to the second one. You see the surface of the lake tremendously decreased, and it was already decreased in this situation with respect to 1960. So basically Lake Aral is almost all dried, and this is the reason for ships being now left on the ground, or a picture like that, a ship over the sand, like in a desert land. What is the reason for drying up? The reason was a massive water withdrawal from the rivers inflowing in the Lake Aral for irrigating cotton fields in the former Soviet Union. A decision was taken in the former Soviet Union to invest a lot of money in cotton production, and this implied a very significant water withdrawal, taking of water from the rivers, flowing into the Lake Aral. The result was was that the inflow in the Lake Aral was almost annihilated, almost reduced to zero. And therefore evaporation caused the decrease in the water storage. And this process turned out to be irreversible, because with the decrease in evaporation due to reducing lake surface, they experienced a decrease in rainfall, which definitely lowered down the flows in rivers. And therefore, they didn't gain the agricultural benefit, and the process, the drying up of the Lake Aral, turned out to be irreversible. So this is an ecological disaster that was induced in a few years by a bad water resources management problem. Keep in mind that climate, while to speak about global changes is a bit tricky, climate at local scale can indeed change as a result of changing land use. So changes in climate at local scale are indeed possible in short time steps. So this is an example that is always cited in conferences. Now, I still have a couple of minutes. I think this is yeah, almost the last one. And I want to close this part by summarizing the Dublin Principles. Why Dublin Principles? Because in 1992, a conference, an important conference, was held in Dublin, in Ireland, on water resources management. It was one of the first conferences that were called at global scale among governments, governmental organizations, to talk about water resources management problem. And they set up some principles for water resources management that should inspire all the solution of all the problems related to water resources management. And let's have a look at the principle, which may seem obvious to us, but they were not at that time. First of all, water is a finite, vulnerable, and essential resource, etc. Everything is obvious. I would say much obvious in the second part. The fact that water is finite at that time was not obvious. Water was considered until 1960-70 an infinite resource. Now we have to realize that it's not. Which means that being finite and being necessary, water has an economic value. And you know, this principle is a bit controversial. because some people and some politicians, rightly in my opinion, refuse to give an economic value to something that is necessary for life. Like, what would happen if we had to admit that air has an economic value, like you have to pay for the air that you breathe? Or what does it mean that you have to pay for water? Because water is necessary for life. So it's a bit controversial, this principle, but indeed, in our current economy, we have to realize that water is an economic value, has an economic value. Water is fine. Water resources development and management should be based on a participatory approach. What does it mean? Decisions related to water should not be taken from the top, but with a bottom-up approach, means consulting with population, consulting with stakeholders. Stakeholders means people that have an interest related to your decision. So you are expected to consult with population, stakeholders, politicians. You are supposed to start a participatory approach, not decision taken from the top. And this is now recognized as a basic principle to ensure a successful water resources management. If you don't consult with people, it's very unlikely that your proposed water resources management procedure is successful. Women play a central role. This may seem strange, but indeed it was recognized that an efficient water resources management should involve women in the participatory approach, because it is not just a question of equal opportunities. It is a question of convenience in this case, because it has to be realized that in most parts of the world, water resources management is a task that is delegated to women. Water has an economic value. I already mentioned this one. Okay, I would say that there are a couple of pictures that put into evidence that it's indeed a task of women, water resources management, and these pictures make reference to developing countries, but something of similar could be cited for Europe. And finally, let me just, what is the role of hydrology in this respect in water resources management? Again, estimation of water resources availability, estimation and reduction of hydrological risks, development of hydrological scenarios. I will explain you what is this, but it's basically a practice that is oriented to estimating the future water resources availability and ensure proper information to decision makers. This is what we are asked to do very, very often. Okay, for tomorrow, I will make a break. I didn't tell you, when I have 2 hours to teach, I prefer to go continuously through the